Hello everyone and welcome to the next episode of Power Logic. So today we're going to be continuing our live solve for the 2022 Aime Ii. So we have a problem. Azer, Carl, John, and Sergey are the four players left in a single tennis tournament. They are randomly assigned opponents in the semifinal matches, and the winners of these matches play each other in the final match to determine the winner of the tournament. When Azer plays Carl, Azer will win the match with probability 2/3. When either Azer or Carl plays either John or Sergey, Azer or Carl will win the match with probability 3/4. Assume that the outcomes of different matches are independent. The probability that Carl will win the tournament is P over Q, where P and Q are relatively prime positive integers. Find P and Q. So, for the sake of simplicity, we're just going to denote the four players as A, C, J, and S. So, now we're going to actually try to consider some scenarios. So first, if John and Sergey plays each other, then we know that the probability is going to be the same. Like, their result is not going to really impact on whether Carl or Azer is going to win. So now, we're actually going to start by looking at all the possible outcomes of the first match. So the first match possibility would be just there are 4 choose 2 over 2, I think. Yeah, so you're just going to do 4 choose 2, 1/2, right? Since you're just going to choose 2 of them, but then we're actually going to consider the possibility because we're double counting. So now, so basically for each of such ordering or such arrangement, then we actually have 1/3 of that to actually happen. Oh, yeah. So now how are we going to actually solve this problem? Yeah, we're going to begin with casework. So let's say the first scenario is going to be if J and S plays a game. Then what is going to be the impact of any of them winning to A or C? Well, because J and S wins each other, or they're actually not going to impact, because when either A or C plays either J or S, then they will always win with the matches probability of 3/4. So therefore any of them winning, then they're going to play with one of these, and then their winning probability will always be 1/4. So we don't even really need to care about who they're going to win. We only want to care about A and C, which if we want Azer, we want Carl to win, then Carl will have a probability of 1/3 to win between these two. So actually I'm just going to minimize this. So if this is such ordering, then we're going to have 1/3. We're just going to multiply this by 1/3. So this scenario will actually give us 1. 1 is between J and S, but AC we're going to have 1/3. And then after that, we're going to have 3/4. Well, why is that? Because after he win this one, then he have to win between J, competing with J and S, and this will actually have a probability of 3/4. So this case gives us 1/4 as a probability. Now we actually have 3 cases, so we actually have to try to think of the other scenarios. Now, what if we have these two play? I'm just going to order it for the sake of clarity. Or what if A and J plays and C and S plays? Then what is going to happen? So first, if C want to win, then C must win S. So we actually have a 3/4 probability. The 3/4 probability of C winning against S and A against J, or J against A. If one of them winning, then the probability will actually change. So we have to do another casework inside this. So 3/4 times if A winning, then P of A. So basically we'll do P of A plus P of B. P of A plus P of J. Now, this is equal to 3/4 times what? P of A is going to be 3/4, and then you want to win against A, you have a 1/3 probability. Now, what if J actually wins? Then we have another 3/4. Then it probably happens 1/4, and then we actually have a 3/4 probability to win against P, to win against J. So this is actually 3/4 times 1/4 plus 3/16. 21/64 if I did not make any calculation mistakes. So now, yeah, 21/64. Now for this one, we actually have to multiply by 2. Well, I'll try to think of why it's that. Because we know that it's not going to change the outcome if we try to arrange C with S or C with J. So I multiply by 2. So this actually gives 21/32 as our probability of such kind of arrangement. Now we're going to add it up. So the probability desired is going to be equal to 1/3 times, well, let's just call this P1. Let's just call this P2. 1/3 times P1 plus P2. This is actually giving us 1/3 times 1/4 plus 21/32. Now it's going to be 21/3. 21 plus 8/32, and then don't forget the 1/3, and give us 29/96. And because 29 is a prime, then we know that this fraction is in the simplest form. So we're asking for the value of P plus Q. So it's going to be 29 plus 96 is equal to 125. And this is indeed our answer. Thank you for watching, hope you enjoy, and I'll catch you in my next video.